So this last few weeks in deep sea exploration has been quite difficult, obviously, because there has been a Titan disaster and 5 people have lost their lives. And I don't really want to comment too much on the details of what happened because, everyone else is chiming in, and I think we're well aware of what happened, and being in the submersible business myself, and over the last 4 years, we've been well aware of the dangers of this particular submarine, and that's probably no secret now. And there's been lots of articles written, and I think I don't really want to go chime in on that one at all. We'll just let the investigation take its course. But what I do want to say is one of the people in the submarine was Paul Henry Nargeolet, or we know him as PH. And he's a French naval officer who has an absolutely extraordinary career in many, many, many ways. He's involved in so many things. And he was a consultant when he went to the 5 Deep, so he came on every single trip we did for a year. And, we became, like to say, good friends. We published some papers together. We shared cabins together. Just an extraordinarily knowledgeable guy. Conflicted between very sad that he's no longer with us, and some degree, I'm angry that he got into that submarine. He should have known better. But it's a difficult one because we're on the ship right now where there are several, at least half a dozen of us on here who remember PH very, very well from this very vessel. And, when the news started coming out that he was on board, and, you're looking across the room, and I sit next to the desk he used to sit at, and stuff like that. It's very, very sad, but he was an extraordinarily cool guy. He wasn't some rich billionaire that a lot of people on Twitter want to take pots at. He was extraordinarily humble. You'll have no idea how experienced and how extraordinary he was. And I didn't for a long time. He just kept coming to my office, and every now and again he would sit down with his big, thick French accent and say, "Well, what are you doing?" And he explain, and then he just delivers this story and this thing, and you're like, wow. And after a couple of times, I remember sitting there going, because he was quite humble. He was quite sort of just this guy character, kind of hanging around a lot of big egos. And after a while, you're like, hold on, wait a minute, everybody stop. Who is this guy again? It's like, who is this guy? Because he's done everything, and
he's really softly spoken. He's just got this really strong, thick accent.
Super humble, lovely guy, and I'm absolutely, genuinely devastated. And it's just really sad. I can see him when we did Challenger Deep. He came into the wet lab one day, and he's like, "I have an egg," and we're like, "What?" What, you have an egg? Okay. What are you going to do with the egg? And he goes, "I have a theory."
Context, please.
Yeah, and he wanted to put the egg down to Challenger Deep on the lander and back, and he did, and it came back, and it did not break. And he was still chuffing himself. That's a very silly little PH story, but in terms of his career, and if anyone has the time, you should do a really good deep dive into PH Nargeolet, and you'll find that there is an extraordinary individual there, and I'm very, very sad that he's gone. So I just want to pay homage to PH. Good guy. I don't know what else to say. It's a sad day it's a sad week for deep sea exploration on many levels. And I think there's going to be a lot of ramifications because of this, but it was not, all I will say is this is something that I guess we all saw coming. We just didn't expect that one of our friends would be in there. You're on the ride with the progress, the Hillsong Express. Oh, yeah.
Hello and welcome to the Deep Sea Podcast, a punk take on a science podcast about everything deep sea. I'm Dr. Thomas Lindley, and out in the field, joining us from the middle of the Pacific is the Professor, Alan Jameson. Hello, mate.
Hello.
Hello. Yeah, so what's Muskie's data satellite jobby that's allowing you to talk to us from out in the field?
We're using Starlink. It works really well.
It does?
Yeah. Since the last episode, I've done 2,800 nautical miles over to Hawaii. Had a port call in Hawaii where we weren't allowed off.
Oh, damn.
Because of various COVID things on it. And we've probably done about another, well over 1,000 miles south of Hawaii now. So we're probably about 4,000 nautical miles into a 6,000 nautical mile trip. Bit of a marathon.
Turns out the Pacific's big.
It's massive, yeah. I'm stopping every 200 miles, deploying everything, and then moving on to the next site. Always on the wrong heading, always, in terms of the direction the ship faces relative to the ocean. So it's been a bit wibbly-wobbly, is a technical term for it.
You said you're realising why the old sailors never really went in this direction.
Yeah, when you cross the Pacific, depending on what latitude you are, you always go east to west or west to east, and you pick your latitude very carefully. Us, however, we're going north to south, so we're always 90 degrees to whatever is coming. no matter how beautiful a day it is, we're still getting pummels every day. It's been over a month now. I think today's day 30.
I've just hammered every single day.
Yeah. It'll be done by day 44, I think. Something like that. I've kind of lost count now. It's not like being in prison.
Not at all. Not at all. You're not.
No, I'm not counting it down at
You're
all.
not going strange.
No, it's not good.
Or remember when we programmed an LCD display once to count down until we could all go to the pub?
Yeah, 500 hours we started at, didn't we?
It was a bit grim.
Yeah.
I mean, it was an amazing opportunity, and it's wonderful to be out in the field. But yeah, you do look forward to home eventually.
Yeah, this was definitely a marathon.
But cool stuff. Some lovely images coming out. We've been sticking them on Twitter. Folks on the Patreon get exclusive.
Yeah, I've been tweeting. I think what was really kind of like great, but at the same time slightly upsetting, is the very first lander we put down. We've done 32 now, and the very first one we put down got a beautiful sequence of the Bathysaurus mollusk, the lizard fish. They just completely, as a complete fluke, just landed in front of the lander. Yeah, 31 landers later, I've never seen anything anywhere near as interesting as that.
Oh, well.
Ah, well, never mind.
That one is particularly interesting because we don't know a great deal about these things because they're sit and wait predators, so they don't come to the landers. And I'm just amazed by how buoyant it was, by how easily it just lifted itself off the seabed. I thought these were dense, heavy things that sort of were well planted on the bottom.
It lifted off the seabed and didn't even stir up a single grain of sediment. It's amazing. Yeah, loved it.
Yeah, it is like a sniper, isn't it?
Yeah.
It is like a ninja.
Yeah.
Just gently lifting off.
Don't get me wrong, we have seen a lot of cool stuff, but it's because we're trying to do this huge, massive. In the end, it's going to be something like 18,000 nautical miles we'll have covered by the end of the year across the abyssal plains. A lot of it is very samey, and it will all come out in the stats at the end. But quite often we're spoiled in the trenches because you're going to unknown places and seeing strange things, and it's very immediately rewarding. This one is definitely a long game where any patterns, trends, or whatever is going to come out later.
And when we're doing the trench work, we're jumping like hundreds to thousands of meters of depth difference when we're doing the trench work. So you see the faunal groups change really quickly.
Yeah.
And this is on such an enormous scale that you're not even going to see the differences, like you say, until you run it all through the stats.
Yeah.
Because it's going to feel very samey because you're covering thousands and thousands of miles.
It's all good fun, though.
Yeah, it is. Be home time soon.
A couple of weeks.
Yeah, I didn't know you couldn't get off in Hawaii. That's not on.
No. We have strict COVID protocols for obvious reasons. Times have changed, and so we can do protocols, but we still have to adhere to various bubbles and whatnot, and which I think is fine because the last thing you want is a nasty little virus on the ship. So
yeah, bouncing around. Well, from my end, it's been an exciting few weeks at Te Papa. Nice things going on. We had a 2-day mass sunfish dissection, which it's about as cool as it sounds. It was really good. So we were visited by sunfish expert Marianne Nygaard. She's described a couple of species, and we just worked through some sunfish specimens that we'd had turn up, like 7 or 8 little cute ones that were like the size of a dinner plate. Then a bit more of a chonky boy that sort of filled the table, but still small by sunfish standards. And they're really weird looking on the outside. And to be honest, when you dissect them, they're really weird looking inside as well. I know they had that like really robust sort of body. Like I thought they'd be more armored, but it's like collagen, and it feels like syntactic foam because they're neutrally buoyant. So it's like all that big bulky body, like so much of it is this weird, like pure white foam. It feels like a resiny foam kind of thing. Oh, it feels like a bit like a really firm, the mattresses, memory foam mattress. Yeah. That's it. It's like really firm memory foam. It's like they're made of that. I know this is grim. This is like a biologist thing, but like it's really satisfying to cut through because it's like cutting through foam. It's like really clean. So many a sunfish dissection.
Is the sunfish the one you were talking about where the guy shot it that said you couldn't fire a...
Yes.
Yeah, okay. Did you try and shoot one?
We did come up actually because they do like a bit of hunting down here. And so we were tempted to test that. I know I've read that. I know I didn't dream that, but we're trying to track down where I've read that. It would have been the old Challenger reports or something like that. It's a proper like old one. But yeah, that you can shoot them with a 22 cal. And it's this weird collagen stuff. It's this weird like memory foam. But I suppose it's like ballistic gel really, like the stuff they put in bulletproof vests. I thought it was like hard. I thought it was armored, but it's like this weird foam. They're weird fish. They're really weird. We also had a member of the public drop in a pineapple fish, which if you don't know what that is, Google it because it looks exactly like you think it does. And then the most exciting one was one of the fisheries observers had put aside a run male short-finned eel. So the freshwater eels here, it's a mystery where they reproduce, just like it is back in the UK and a few other places. We just know they go to sea. We don't know where they go. And this was the first time a sort of ripe male that had left and gone into the ocean to reproduce had turned up, and it was just absolutely packed with gonads, and the body had sort of been reduced away, like the bones had all gone a bit soft. Its got eyes had gotten really big, so that's obviously some key element to them finding a mate. And yeah, so got excited about that, called a few people, and we'll have a little sesh where somebody comes and we have a look at these eels.
Well, you've been having fun.
Loving it, messing with some fish. Also been chatting with a good few listeners. I know a lot of scientists listen to this podcast while they're processing their samples, just to keep their brain active. So if you're sorting through a jar of bugs right now, you've got this. Keep at it. And also, the greatest compliment a podcaster can receive is people listening to our podcast to go to sleep. So for you, Jamie, night. And Kerry, I know, don't find this weird. Me and Jamie just have our little nighttime ritual. So sleep tight, Jamie. Sleep tight. There we go. That's destroyed a marriage.
And I interject you and say, what the hell are you talking about?
Somebody listening to the show to go to sleep, and it's unfortunately for them somebody who knows me in the real world. And his wife finds it really disconcerting to hear me chattering away from the corner of the room.
Oh, let's have some fun with that. Let's do a bedtime story. I've got a few stories we can tell. Yes, let's have whoever Jamie is, we're coming for you, and we're going to freak your wife out.
Excellent. Well, that's lovely. Also, nice chats going on over on the Patreon, over on the Discord. We've been talking about tattoos, actually, and everyone's comparing their marine tattoos. And to give a shout out to new patrons who are supporting the show. Well, the first one I did a double take of, Tammy Frank.
Yes.
Tammy, who was a guest on the last one, is donating to this nonsense. So thank you, Tammy. Also, Martin Polizotto, Ray M, Nicole Veit Label, Anna P, and Eric. Just Eric. So thanks, everyone, for joining the Patreon program and helping us keep the show going. Do you have a soundtrack, Alan?
We have a soundtrack, and because when we deploy and recover landers on this particular ship, we like to play some good old classic metal. And so the soundtrack to this particular trip is probably Pantera, Cowboys from Hell.
Oh, nice.
Yeah.
Okay, I'm going to stick with yours. That's a good one.
Pantera, I've got that groove. They've got that groove. Yeah, perfect lander deployment groove.
Okay then, music to deploy landers to.
Yeah, you can't hear anything that's going on the radio because of that, but it's probably breaking all sorts of health and safety regulations, but I'm sure it's fine.
It's great for morale.
Yeah.
It's morale that's important.
Absolutely.
Cool. Well, some deep sea news. I will start off with, it was the New Zealand Marine Science Society conference, and our very own friend of the show, Ash, was one of the organisers, and so I caught up with him in an empty lecture theatre just before it started filling. We only had like 10 minutes to chat quickly, so I talked to him a little bit about organising a conference and even organising the big deep sea conference with James Cameron as the opening act, and it turns out behind the scenes that was rather stressful. Ashley, it's good to see you, mate.
It is good to see you too. Now you're in New Zealand.
Now local. We can
now
have lots
local.
of chats.
You'll turn into a Kiwi soon.
I'll get there.
And you'll mangle your accent like I've mangled mine over 20 years.
Mine's pre-mangled.
Is it already?
Yeah, because I'm a Brummie. All this is lies.
Is that right?
Yeah, we're going to talk about this at one point on the show, but I'm just an absolute fraud.
That is amazing. And Brummie being one of the strongest accents, it's pretty hard to hide.
Exactly. Voted least sexy accent.
I know, probably after the Welsh accent, which is probably why mine's been so suppressed as well.
No, they love the Welsh. So how's it going?
Going well, yeah. Big job to organise. As you know, scientific conferences are sort of organised most often by the scientists themselves and teams of volunteers and students and whatever. So big effort. But we're on day 3, last day, which is great. It's a local conference, so it has that sort of community feel. People are very forgiving of the mistakes and what have you. And as long as you've got good food and plenty of booze, most people are happy. So
it's a really young conference. It's
that's quite typical.
Early career.
Yeah. So normally you see at least a third of the talks be given by students. Sometimes, even up to half. I remember one conference a couple of years back. I did the student assessment of their talks, and it was like half the talks, and many by master students, so not just PhD students. And the quality is amazing, I think, for the young age and stage in the career that a lot of these
that's what's really surprised me.
Is that right?
Yeah, we're going to be okay. Like the youngs are really, really good. Like I know it's taught more as a skill. Like maybe when we were coming up, sort of presentation you learned on the hoof.
That's right.
But like the quality of the slides, the confidence of the delivery, these student talks are really, really good talks.
No, absolutely
enjoyable.
So, and this morning is a good example. The plenary talk this morning, so a 3/4 an hour talk, was given by the previous year's winner of the Student Research Award. So she's only like 8 months or something into her PhD, and she gave the most, brilliantly confident talk, clear and everything, for 40 minutes. I mean, that takes some doing.
That's a long time. That's
really
a long
good
time for an early talk.
No, so you're right. Lots of encouragement to be had from just the proportions of the people that are here.
And then this like nice, gregarious atmosphere. There's some jokes, there's some levity.
No, that's right.
Everyone's genuinely curious. There isn't that sometimes you get that sort of scientific like, or you're encroaching on my area,
right.
and
my stuff's better than
I
yours.
did this 20 years ago, and mine was better, and
that's much more a rare occurrence here. It is much more. Everyone knows that we don't have many resources in New Zealand to do science, and therefore we need everybody doing it. And so you don't want to put anybody off. And what you're meant to be doing, of course, is helping anyone you can see might be struggling. So, when talks are given, people are being as constructive as they possibly can. No one wants to put anyone off. Yeah, so that gives a nice feeling.
It is. It's a really welcoming one.
Yeah, cool.
I really enjoyed it.
Well, I'm glad for your first one.
Yeah.
So the other thing is that every third year or something, we do a joint one with our Australian brother-sister organisation. So next year is actually in Hobart, Tasmania.
Oh, cool.
Yeah, so we have a joint one every 3 years.
Yeah.
They're much bigger, of course.
Yeah. Oh, well, that's good. That's good. And deep sea session all day today.
I know. So
which wasn't originally a plan. It was just by the weight of abstracts.
That's right. So when we obviously ask for abstract submission, then the person who's developing the program just looks at what the sort of distribution of the talks and comes up with the session themes. And lo and behold, a whole day on deep sea ecosystems, the most talks in any one session. So 15 talks in this session, taking us the whole day to get through those, which is terrific. Unfortunately for me, I'd originally, being on the organising committee, had said, oh yes, everyone has to chair a session. I thought there may be about 4 talks on the deep sea, but it's 15. So I'm here now with my PhD student, Katie Bigham, chairing the whole day. So
it was meant to just be a little session.
I know, a little session which I could have taken it easy.
But this wasn't one of the original categories, and so this reflects a deep sea preference to New Zealand science.
That's right, and at least an interest. So there's a variety of talks out of that 15, but looking at it, it looks like there's sort of 2 main themes, I think, that come out. One is the sorts of concern about human impacts in the deep sea, fishing and potential mining and things like this. And then the other is understanding the biodiversity of the deep sea, particularly for New Zealand, where we have relatively undersampled. We don't have often the resources to take the typical deep sea samples from ROVs or things like this. And so people are trying to discover what that biodiversity is, and using different techniques, genetics, using benthic bycatch, anything you can get, and using, for instance, the value of archived material. So we've been sampling in New Zealand water since the 1950s or so, and so there's quite a large collection, particularly at NIWA, one of the institutes that I work at, which is available for researchers across the globe to come and utilize. And we saw today, this morning's session, because we still got this afternoon's, where people were using those samples.
Yeah, going way back into the archive, and then you've got before and after.
Yeah, deep sea corals, let's get them out. Let's see what we can do with them, the genetics, using them for paleo, climate change detection, etc. Big
earthquakes, a heat event. We've got the previous state as well.
Yep.
Can I get the Cameron story from you? Is that too much of a tangent? Because it was so...
Yeah. So these are sort of stressful events, organising them. And luckily, I'm not the lead organiser for this one. So that's great. But I did was the lead organiser for the Deep Sea Biology Symposium, which was here in Wellington in 2013.
That was huge.
That was big, yeah. And to get it in, it was the first time that symposium had been in the Southern Hemisphere. So it felt a bit of a coup to get everyone here. And one of the little draw cards that we played was the presence of James Cameron, the film director, who actually partly resides in New Zealand. And I'd actually met him before, and so I thought maybe I'll just reach out to him and ask him, would he do the opening talk? And because he'd recently dived through the bottom of the Mariana Trench, in his submersible, and so he agreed, which was absolutely terrific. A lot of organisation about how you meet such megastars and so forth. He arrived by helicopter. I came on my bike, and then the biggest. My worry originally was, would we have enough people in the morning who would turn up? Often the opening address, some people come a bit late or whatever. So I had told a few of my friends that James Cameron was going to be talking, and the auditorium was absolutely packed, standing room only.
Grandparents,
children who were clearly not registrants in their school gear on their way to school, and thought, that's great, that's terrific, we got a full house and what have you. But then it turned out he brought his presentation, his video on the wrong...
8K raw footage.
Right.
No university computer will ever play.
The computer would not play. And so we're standing there, just sweat dripping off me, and he's thinking, this isn't going to work. And then the projectionist, who was at the back of the auditorium, came down and said, what's the problem? And we said, look, it's rendered in the wrong way. James Cameron came up with the notion that he could call up the film production studio, which was in the nearby suburb, and they could get him a new one. And the projectionist volunteered to get on his motorbike and shoot with a pen drive. Yeah, with a pen drive over to their studio, and then come back. Meanwhile, I had to entertain 350 plus people, including children and grandchildren, while we waited for this film to come. Anyway, Julie arrived with the guy running down the auditorium, step by step.
Like a heart transplant.
That's right. Still wearing his motorcycle helmet with this video in place. And we plugged it in, and off he went. There was a big roar, from the crowd. Like, yeah, it's on. The whole thing, of course, the rest of the conference was completely delayed because of that.
From talk one.
Yeah, from talk one, we lost the program. So it was a very stressful moment, but nonetheless fun.
Excellent. Cheers for chatting. Yeah. As you can probably hear, the room's filling up.
Oh, yes,
so
it is. We've got to go. We've got to start chairing the session. All right. Cheers, Tom.
Ash was also awarded the John Morton Medal for advances in marine conservation and sustainability. So nice one, Ash. Well done, friend of the show.
Good job.
He reluctantly accepted it because he's humble and lovely. But yeah, he has a medal now. He better be wearing it.
I don't think he likes medals. He doesn't strike me as the kind of guy that would receive that well. Yeah.
No, I had to go up and get it and everything.
Oh, God, he must have been mortified. In a good way. In a good, humble way.
Yeah.
Yeah, not in an ungrateful way.
No. Very, very humble, very supportive person. Lovely Ash. A new species, and maybe even sort of a new higher level taxon of a gelatinous predator has been filmed. So EV Nautilus, all the live streaming is going on right now. So if you're into your live streaming, have a look out, because I think them and Schmidt are streaming right now. So lots of cool things to watch. And they were out at 1,400 meters in the Pacific Remote Island Marine National Monument, and saw a pretty cool looking orange jellyfish that I think looks a little bit like the tripods from War of the Worlds. So they think it likely belongs to the Bathychorus genus, but it has this interesting brown-red pigment, obviously to block anything that it consumes, lighting it up, so to hide from predators as well. And it has just 3 tentacles. So apparently triremus jellyfish are extremely rare.
Wow. It looks kind of like a Narcomedusa, but it's only got the 3. I'm getting kind of fascinated by Narcomedusa. I saw one the other day.
Oh, yeah?
And they have 4, but the tentacles come out of the top of the bell rather than hanging down below it like a normal jellyfish do. But that one does look particularly odd. Never seen anything quite like that before.
It does look like the tripods from War of the Worlds,
yeah,
doesn't it?
But thankfully it's probably tiny and not something that can hover over a city and destroy it, which is really lucky.
But you can see where the tentacles originate in the same place, and then they sort of pass up through the bell with this quite spider-like elbow joint. Very, very cool. Just off Taiwan, in Taiwanese waters, a goblin shark has been trawled up, pregnant with 6 pups. 800 kilograms, that's about 1,700 pounds, 4.7 meters long, over 15 feet. Yeah, and it was originally going to be sold to a restaurant, but the Taiwan Ocean Artistic Museum, which sounds pretty cool, talked them into giving them to it, so it will eventually go on display. And it had 6 pups inside it. It was a pregnant female. They give birth to live young, and they're one of those sort of things that are touted as a scary deep sea thing, but they look awful dead. They're pretty creepy alive, but they really look quite horrific dead. That extrudable jaw is usually held sort of retracted in a more sort of sharky looking head. But when they come up, they've got really sort of loose gelatinous flesh. They always have like blood capillaries bursting.
Well, they're relaxed, don't they?
Yeah.
The whole mouth relaxes and it just looks like it's some big mad thing. But yeah, bad PR.
And quite bloody as well. So it just, they look far scarier when they're up. But, you know, it is a big toothy looking predator. So it's one I'll allow for being a bit scary.
Did anyone look at the pups to check to see if they looked like plastic toys?
Yeah, if they had a seam on them or not the right number of gills.
Yeah.
We've got data on what the pups look like now, I guess.
Yeah.
It's not an entirely new discovery, but there's a really nice little post in Nautilus on the largest bioluminescent organs, which belong to the Dana octopus squid. And they're called octopus squid because they've only got 8 arms, despite technically being squid. They lack the feeding tentacles. They can get to over 2 meters long, so about 7 feet. But what's really interesting about them is they've got these massive photophores. So on the 2 stubbier arms, they've got these lemon-shaped and sized, actually, huge photophores. So they can actually emit really, really quite high-powered bioluminescent light. Lots of theories about what that might be for, and they can sort of flash them as well. There's a sort of lens over it and an eyelid essentially over it where they can make it pulse. And I always wondered if this was like, remember when Edie Widder was talking about? Oh, I think no, actually it was one of the Triton boys talking about flashing and something flashing back.
Yes, Frank.
So one of the party pieces from the subs is to flash a torch and something out there flashes back. And I wonder if it's these squid. It seems about right. They're not entirely sure what they do this for. The other one was just a little side note. I noticed in some of the coverage of World Ocean Day that on the BBC coverage, they still said aliens for deep sea critters, but it was put in inverted commas. So like maybe we're making progress. Maybe the message is getting through. No. They still say aliens, but they put it in inverted commas.
I don't buy that.
And speaking of not buying it, I'm really not sure how I feel about this. I need to do a bit more research. Have you seen Dr. Deep Sea did 93 days underwater, which set a new record?
Yes, I did, but I'm very skeptical about all of that.
Yeah, I did a little bit of digging, and I'm not super liking what I found. Like the record is really good, and he seems to do lots of stuff with kids and ocean stewardship and sort of discovering new things. But then the reports after it started coming out about, and I'm going to put my skepticals on for this. I'm going to read this with my skepticals. Apparently a 20% growth in telomere length, which are the areas at the end of our DNA that apparently get shorter and shorter as we get older, and it's sort of a sign of aging. And also 10 times more stem cells than at the start of the research. And that just started to sound a little bit pseudoscience-y. And then reading some of the reports, there's quotes like, however, pressure, such as is found in therapeutic hyperbaric oxygen chamber, has been shown to have several benefits, which living under pressure of the waves seems to have replicated. But then no citation. Nothing to then back that claim up. And then with a bit more digging, it seems that Dr. Deep Sea owns a private clinic where you can have pressure treatment.
Yeah.
And I was digging around a little bit more, and the sort of the most detail I could find about this was an equation which just said oxygen plus pressure plus breathe equals advanced healing power. And that,
all right, I'm out.
That made the alarm start ringing.
I'm tapping out with that one. Hey, of interest, I can't remember where did he spend the 93 days? Actually, what depth, and was he actually like in the water, not just in a tank or in a vessel?
Oh, it was, I think it was like 20 meters, like despite calling himself Dr. Deep Sea. But yeah, it's like 20 meters. You can see the sun. There's a diver waving through the glass. So it was at elevated pressure.
But he's in air?
Yeah, he's in a habitat.
Okay, so I'm tapping out with this one. Let's not give this guy any more time. That's just nonsense. Advanced healing power, blah, blah. Nah, nope.
Yeah, because it's a lot of chat that's going on the back of this sort of record being set, but I've only got to dig a little bit until it's a product, which is what I didn't like. He was a military diver, and he's written some papers on sort of treating decompression sickness, but all of the health benefity stuff gets really, like, I couldn't find a single paper. I couldn't find any references. Just this equation that equals advanced healing power. So yeah, tapping out on that one.
I can offer advanced healing power, I think.
Well, I wanted to get you to tell the story, because remember this came up before. Do you remember a friend of a friend heard about the advanced healing power of a barometric chamber and decided to build one for Nana?
Oh, yes, that was chief engineer on the Kaharoa. Yes, that's right. And they had all sorts of problems. And then poor Nana got incapacitated inside the hyperbaric chamber in their back garden. Yeah. Oh, I can't remember the exact details of that, but it was pretty mental.
Yeah, someone had seen this in the news that pressure oxygen treatment might be a cure-all, and built a barometric chamber in their back garden and decided to pressurize Nana to heal her. And I think she blacked out and was rushed to hospital.
Yeah, so a public service announcement: don't pressurize your nan. It's never going to end well.
I'm sure there's an act to it.
Yeah.
Oh, so shall we have a guest this week?
We probably should. Rather than talk about advanced healing power, maybe we should talk about good, solid geology. You know, stuff that's like there.
Oh, good, reliable rocks.
Good, reliable rocks that don't lie. There's no major interpretation. It is what it is.
Now, I know for a fact that there's a lot of interpretation in geology.
Don't ruin it. Don't ruin it. We're trying to make a segue here, right?
I know. Sorry. Continue to segue away.
Yeah, so geology does not lie. And rocks are rocks, mud is mud, pebbles are pebbles, cobbles are cobbles, boulders are boulders, and so on and so on. Tectonics is a thing. And so that's the opposite end of the spectrum from advanced healing power. And so we should talk to someone who drills big massive holes in the seafloor for fun and science, I think.
Excellent. So anyone following the news recently might have seen there was the deepest hole dug in the seabed. This turned out to be an interesting legacy that's been going on since about the 1970s. The quest for the Moho, the hole that would give us mantle rock from below the Earth's crust, basically, to penetrate the Earth's crust. And yeah, it's happened a few times, but this particular expedition 399, Building Blocks of Life, got in there. So I'm going to have a chat with Dr. Andrew McCaig, one of the co-PIs on this recent drilling trip. I'm joined by Dr. Andrew McCaig, Associate Professor at the University of Leeds in the UK, and his research focuses on the structural geology, tectonics, and geochemistry. He was recently the co-chief scientist of the IODP Expedition 399, Building Blocks of Life, Atlantis Massif, that sailed between April and June 2023.
It's mantle rocks which have been exposed on the seafloor that we drilled into. They've been exposed there by faulting. But the previous record was 200.9 meters, and we did 1,268 meters. So we exceeded the previous record for drilling into mantle rocks by more than 5 times. So that was the achievement, and it means we've got very continuous. What we're recovering a drill core here. It's about 6.5 centimeters in diameter, and what we got is very continuous sections of drill core, so that the scientists can look at that in great detail as we move forward with post-cruise research.
And by getting sort of deeper into the mantle rock, I'm guessing exposed mantle rock has sort of started to change, started to be impacted, started reacting with the seawater. Is this sort of a purer example of what's going on inside the planet?
Well, it's deep inside the planet that the mantle rocks are not reacting with water, certainly in the way that they are doing here. So the mantle's made of peridotite rock, and peridotite is the main mineral in that is olivine. And typical mantle rocks are maybe 70% olivine. And at depth, if you're, let's say down at 50 kilometers or something, that's very hot. And the only place where water gets down to that depth is in subduction zones. But we're at a mid-Atlantic ridge where basically the water can only go down maybe a few kilometers. So what happens when these mantle rocks get exposed on the seafloor is that the water can get at them really easily, and the mineral olivine alters to the mineral serpentine. And serpentine, you can think of it as a hydrated version of olivine. It's got more or less the same magnesium and iron and silica in it, but it's got water added to it. And that process of serpentinisation is really interesting, because in that process, what you have is the olivine mineral has about 10% of an iron-rich M member, and that iron is in the 2+ state, it's Fe2+. But when the changes to the serpentine can't hold all that iron, and so it throws that iron out, and what that does is it changes into magnetite. Now, magnetite is a mineral which contains both Fe2+ and Fe3+. So what you have here is a redox reaction. So you oxidize the iron from Fe2+ to Fe3+, and you need to reduce something else. So you reduce seawater from H2O to H2. So this process generates hydrogen gas, and that hydrogen gas is then what we would call in our expedition, though some people might dispute this, the first building block of life. And then that hydrogen gas can combine with carbon dioxide, which may be either from the ocean or it may be deep-seated carbon dioxide coming from deep in the earth, because the earth is degassing a certain amount of carbon dioxide all the time. So reaction between carbon dioxide, CO2, and hydrogen, H2, makes CH4, which is methane. We're all familiar with methane. That's what we burn on our cookers still at the moment in order to cook our food if we have a gas cooker. So that's methane. Now, most methane in the world is generated by biological processes, by animals. You know, we've all heard about this in the context of climate change, that cows and sheep are eating grass and generating methane, and that methane is contributing to global warming. And this is the normal way it happens. But here, what we're seeing in the serpentinisation is you're making methane by abiotic processes, by processes that don't require any microbes or that sort of activity. And then what we see as well is we see higher organic molecules like formic acid and acetic acid. So these have now a carboxyl group. So now the methane is combining with more water and so on. It's making more complicated molecules. And then finally, in the Atlantis Massif, previous workers have detected some amino acids, tryptophan, which is an amino acid. Now, this isn't one of the amino acids that's in DNA, but if you can make amino acids without any biological activity, then this is what you need to do in order to, before you can possibly have life, if we believe in the evolutionary version of the origin of life. So people are very interested in serpentinisation, and they're not just people who work on rocks in the Atlantic Ocean. People who work on the icy moons like Enceladus and Europa and so on. These moons have got icy surfaces and water underneath the ice, and underneath that water is the same stuff as the Earth's mantle. We know from meteorites that most meteorites are made of essentially mantle rocks. They're the breaking up of planetary bodies which are similar to Earth. And so the speculation is that just as microbial life might have evolved in places like the Atlantis Massif, where seawater can interact with olivine-rich rocks, that the same thing might have been and might indeed be happening on icy worlds out in the solar system. So it's a very interesting place, the Atlantis Massif, for astrobiology as well as for marine geology.
Looking down to look up.
Indeed. But the other interesting thing about our hole is that we also had on the ship 4 microbiologists, and the microbiologists were collected a whole set of samples every 5 meters or so down this hole. For 1,218 meters, they got a sample. And those samples, we think that the bottom of the hole now will be probably at more than 120 degrees. I mean, at the moment, what we've got is some temperature measurements in the hole, which go up to just over 90 degrees. But just before we'd done that, we'd flushed cold water into it for an extended period. So the temperature was warming up in over a period of hours. And we think that in a few years, we'll be able to go back and measure the temperature, and it'll probably be above 120 at the bottom of the hole, which is above the current limit for life. So potentially the microbiologists have got samples in these serpentinized rocks where they find archaea, bacteria, microbes and things like that, ancient-looking microbes in terms of their longevity. And they can constrain what's going on in the rocks over that temperature gradient, which will be really exciting. Of course, we don't have any of that data yet.
Yeah, it's always frustrating. Everyone wants the results when you come back to shore, but it's like, that's a year, 2 years away maybe. There's a lot of work to be done.
Exactly.
This is very close to an area we've discussed in the past. The Atlantis Massif is kind of next door to the Lost City. It's the same processes going on there, isn't it?
Exactly. So the Lost City hydrothermal field is on the top of the Atlantis Massif, and it's only 800 meters away from the deep hole we drilled in Serpentinite. So we're drilling into the substrate of Lost City. So, what's underneath Lost City, the fluid's coming out of Lost City at more than 100 degrees. It's come from pretty deep down, and it's gone through rocks similar to the ones we've drilled. So we can look at what's going on in there, and we can hopefully make better constraints on what's going on underneath Lost City and where the hydrogen and methane that are found in Lost City hydrothermal field are coming from.
Oh, exciting stuff. And is that your particular area? Is that what excites you, the potential origins of life?
No, it's not really my field at all. So the way that this whole thing started, I'm more of a petrologist and structural geologist, if you like, a geochemist to some extent. So I worked for a long time on shear zones in the Pyrenees. I was an on-land geologist, and then I moved to kind of fault rocks in the ocean. So my interest in the Atlantis Massif has been historically mainly in the fault that exposed these prudatites and also gabbroic rocks, which are the lower crustal rocks. But going back to what you asked about my expertise, so the process of getting an expedition approved is quite a long one, and it started in 2018, and I just got together with my mainly with my petrological friends, and said, why don't we drill a deeper hole in the Atlantis Massif? That would be interesting. And so we put together this proposal. Deepening hole 1309D was its first thing, which was what the original intention was. This is that hole in the 5 kilometers away in the Gabbro. And so we were going to deepen that, and we were going to get down to places where the temperature was about over 200 degrees, and look at reactions between water and rock that were going on down there. And then I realized that when you're getting one of these international expeditions funded, you need to have as broad a coalition of people as possible. And obviously, I was interested in Lost City, and I'd been a co-proponent of another expedition, 357, which had drilled shallow holes in the vicinity of Lost City. And so I said, oh, well, why don't we, we weren't going to put microbiology in because our hole was going to start at 1040 degrees above the limit line.
Yeah, supposedly beyond.
Yes. So we thought, well, the microbiologists weren't very interested in that. But what we did do, we said, well, we'll sample waters in it. And the water in that deep hole, which we did sample, that has this whole temperature gradient. So the microbiologists are interested in that, in the microbes that might be in the water in the hole that was been undisturbed for 13 years or so. But then we introduced this extra hole, and we never expected it to get below 200 meters because that was the deepest anyone had got before. But we brought the microbiologists because they were very interested in the rocks from these serpentinized peridotite rocks, to get more of those rocks. And the way the science was written was that I found co-proponents, Beth Orcutt in particular, who helped with the microbiology description, and Susan Lang, who's the other co-chief on the organic geochemistry side of the proposal. So I don't make this proposal by being an expert in everything. I know about the structural geology and things, I can write all that. But I get other people to collaborate who can do this. So it's a completely multidisciplinary international team, 26 scientists, all from different countries all over the world, Japan, China, India, Australia, Germany, France, America, and Britain. So those are all the countries that we had scientists on the expedition. So I think this IODP is an exemplary program in this sense, because all the data is free of access after a year of moratorium. So anyone can go and interact with that. They can go and collect samples and so on.
This is a nice sort of nexus point over a few of our previous episodes. We spoke with Mandy Joy about the deep biosphere and the sort of theory of how deep life goes and how much there is. And we even spoke to Kevin Hand about potential life on the ice moons and how much it felt like a deep sea habitat, really. And even discussing that if you transplanted a hadal amphipod to Enceladus's ocean, it might starve rather than die immediately. It might live long enough to run out of food.
It might, yes. So, we are generating food for the microbes in Lost City and potentially in the rock, because what do they need? Well, they can't rely on photosynthesis because there's no light. So they're chemosynthetic bacteria. They rely on chemical reactions to give them energy. We live off carbon, which is generated by microbial and biological activity. We eat plants, we eat animals.
It's fixed into a form we can use it.
Yes, we don't try and get our carbon directly from carbon dioxide, but in the bottom of the ocean, they need to get their carbon from somewhere else. Now, of course, once you've got some microbes, then new microbes can eat the old microbes and so on. But in the early days of life, they had to be capable of getting their carbon from abiotic sources. So people are very interested in the microbes that still do that.
There was a record of previous microbial life as well, isn't there? Not just what's extant right now and living, but there were records of both the Earth's previous climate and life, wasn't there?
Well, we can find in rocks, 3 billion year old rocks, we can find stromatolites, which are microbial mats. I'm getting out of my comfort zone now, but you can certainly go back a reasonable way. And some of the microbiologists in our ship, they don't look at the microbes themselves. They look at the fossil microbes, if you like, the organic matter that's left, and they do DNA sequencing on it. So we had interesting different microbiologists. We had Gordon Sutherland. He's very interested in living microbes. He was finding microbes that were living off bits of the inside of the drill string, which is metal. They were growing from iron oxidation, rusting basically metal in seawater. And we have Fengping Wang, who's from China, and she's a very famous microbiologist. You can look her up on Wikipedia. And she specializes in culturing in the laboratory. So she's doing these things right at the limit of life, culturing them for many years, and then seeing, well, okay, these microbes here have survived at temperature X. If I put them in temperature X minus 20, then they grow. And she collected lots of specimens, which she's put into little pressure vessels and taken back to China to do these experiments in her lab. So a very, very interesting set of people.
Yeah, really broad team.
Yeah, exactly. Yeah.
So doing this required some old technology and some very new technology. You mentioned you sort of revisiting a hole that was bored previously, and it was bored quite a long time ago, wasn't it? Was it about 20 years?
Yes, in 2004-5. we were there over Christmas and New Year. So yes, it's been there for a long time. And what we do with these holes, we put what's called a re-entry cone onto the top. There's a re-entry cone and some casing, which just protects the top of the hole from bits of rock falling into the bottom. And so we'd put this re-entry code in back in 2005, and it's still there now, and we were able to re-enter it. And then we've left this new hole with a re-entry code as well. So that means that hole 1309D, it was re-entered after 7 years by an expedition called 340T, which was just a logging expedition and temperature measurement. So they just lowered geophysical instruments down the hole with the drilling ship. They did logging with the drilling ship inside the hole and measured the temperature, which was really very interesting. And then it was left for another 13 years, and we went back and went back into it and sampled water in the hole to see whether in the intervening 13 years since it was last disturbed, we'd had reactions go on between water and the rock in the deepest parts of the hole. And we measured the temperature gradient again, and then we did deepen the hole by another 80 meters, and we got some rock from down the bottom there as well, including some samples from microbiologists so they can prove there's no life at 140 degrees centigrade.
It's something that's just very easily said. We re-entered a hole that we had previously drilled, but these are over 2,000 meters deep. You're on a moving platform, but way above them. How on earth is that achieved?
Well, basically, we know the latitude, longitude of the hole, and we take the ship to that latitude and longitude. And then the ship, the JOIDES Resolution, I mean, like all drilling ships, actually, it's a 50-year-old drilling ship. So in drilling ship terms, it's pretty old tech. You can go on a tour around and you can go in the shack where they control the drilling, and it's got, knobs and dials and things like that. Those old school things that we used to have on instruments. Oh, and then they've got a crew of about 5 guys who are tripping the pipe, which I'll come to in a minute. So it's quite a labor intensive thing. Well, now on a modern oil field drilling ship, it's all pretty much robotic, and it's all controlled from a dedicated computer in some place not very near the rig drill floor.
No one's getting muddy and wet.
No, exactly. Only if they have to fix something. But anyway, how do we find the hole? Okay, well, what we have to do is we don't have any submersible thing that can we don't have an ROV that can go down there and look for it. What we do is we just sit there on the top of the seat and we trip the pipe. And that means that we put a 30-meter length of pipe. We first prepare, the guys first prepare the drill bit and what's called the bottom hole assembly. So it's a drill bit that's about 1 foot across, but it's got this about 6.5 centimeter hole in the middle, which is where the core comes up. So it's like a drill bit which can drill a hole in the rock, leaving a sort of column of rock that pokes up through it. And then it's got a bunch of rather heavy bits of pipe that give it a bit of weight near the bottom. And then above that, this is drill string, which is wider than the piece of rock, and it's in 30-meter lengths. So they basically lower what's there already down, get hold of it, use the derrick and a crane and so on that's all organized to pick up another 30-meter length, screw that into the what's there already, and then they drop that down 30 meters, grab hold of it again, put another 30 meters on. So we get down, the 1309D hole was actually at about 1,600 meters below the seafloor. So you can work out how many lengths of pipe they had to put in there. So 50 odd lengths of pipe to get down there. And then when you've got down to the right depth, you send a camera down. So there's a frame that they can clip around the drill string and drop that through the moon pool. So in the middle of the ship, there's a big hole. That's called the moon pool. That's where the drill string and the camera and everything can go down through that. And you go down with this camera and you can see the bit and you can see fish swimming around and things like this. And then they just look around for the cone sticking up. So it's basically, you go down there, you do a camera survey, which means you just say, okay, we think we're in the right place here. We'll just sort of spiral our way out. We'll go up a bit, sideways a bit, down a bit, sideways, until we see the drill cone. And the first time we re-entered, it took about an hour, perhaps, to find it.
Really impressive.
And we're talking about something which is like 2 meters across here at 1,600 meters depth. And there's no very high tech in doing this. Well, I mean, there's GPS positioning. The ship has dynamic positioning, which means it has a set of thrusters that can keep it on station if the wind's blowing and so on.
I'm guessing there's a USBL on the end, so you know where the bit is relative to the ship?
Not really.
Really?
We assume it's directly below, but if there's a current, it won't be directly below. The drill string, it has a certain amount of flex in it. And I mean, obviously we have a fiber optic link to the camera, That's the only electronics we have at the bottom of the drill string. We were able to collect bottom water samples by a bottle on the drill string as well, which was triggered electronically. But otherwise, it's not very high tech at all, really.
Oh, is the drill bit itself hydraulic?
The drill bit is turned from the top.
Oh, right. Okay.
It is possible to have a drill bit that is turned by a so-called mud motor at the bottom, and we did have that technology to try and install a re-entry cone, which actually failed in the end, and then we tried a different way. But in terms of finding the bit itself, once we got into the hole, then we need to trip that pipe another 1,400 meters. So that's another process, several hours of tripping the pipe to get down to 1,400 meters. And then we turn the whole drill string from a motor in the derrick at the top of the ship. So the drilling is controlled from the ship, and then we're able to sample the core. What we do is we put what's called a core barrel, which is basically a plastic tube. We drop that down through the drill string, and it just sort of latches itself right at the bottom, just above the drill bit. And then as you drill down, the core kind of comes up into that barrel, and then when you've got 5 meters of core, when you drilled 5 meters down, then you can send a latch key, if you like. You drop that down the drill pipe, and that has to be done from right at the top of the derrick. So there's one of the drillers hoists himself up in a harness
with a 5-meter drain pipe,
puts this into the top of the pipe. It drops down to the bottom on the end of a cable, which is onto the thing, and then we can pull that up again on that cable. We don't have to keep changing the bit in order to recover core, but every few days the bit wears out, and we have to triple the pipe right back up to the ship again, change the bit on the ship, and then trip it right and put it right down again. So it's typically 3 to 5 days of wear on the bit, and we have to change it.
Wow.
But we were getting core, 5 meters of core in 1601C every hour and a quarter. So every hour and a quarter, a new set of core would come up for the core describers to describe. So they had a lot of work to do.
Yeah, that's loads of material. That's quicker progress than I had in my mind.
Well, we were very surprised at the progress we got in this hole. I mean, in hole 1309D, we were going at about 1 meter an hour, 1.5 meters an hour. But in terms of drilling rate, we were up at 5 or 6 meters per hour. In the 1 hour and a quarter, a lot of that was just sending the core barrel down and sticking another length of core out. So it was remarkably quick and remarkably trouble-free drilling compared to expectations.
Brilliant. So you weren't anticipating setting a new record. It just went extremely well.
Well, we were hoping to set some records in hole 1309D, actually. So we just failed by about 5 meters, or 8 meters, to drill the deepest ever hole in Gabbro. We got close to it, but we didn't. We decided when we got this such favourable drilling in 1601C that we preferred that hole. Oh yeah, let's deepen this one because it's in the spentonite. Yeah. No one's done that before. So we weren't expecting to beat the 200-meter record for a hole in spentonite peridotite, but we did. And the science part just said, let's just keep drilling here. This is really exciting.
Don't interrupt a good thing.
No, exactly. So yes, so we were expecting to set 1 or 2 records, but we set different records from the ones we expected to set.
You've got to be flexible out there. I spent years writing those grant proposals, but you've just got to roll with the punches when you're out there.
Well, absolutely, and we had a few punches of other sorts.
Can we talk about the sort of history of this project for a while, and then maybe look into the future a little bit? Because the sort of idea of deep sea drilling sort of began in the 1960s, and there was a very successful project during that time, and then funding dried out, and it was a project that was sort of a dream that was sort of left for a while, and it was only quite recently sort of reinvigorated, and there's a bit of uncertainty going forward, isn't there?
Yes, so it started as the deep sea drilling project. There were quite a lot of aims for the deep sea drilling project, but one of the aims was to drill a Moho, i.e. a hole through the Moho. And the Moho is the boundary between the crust and the mantle. So underneath Britain or New Zealand, that's down at 30 kilometers or so. And, out of reach of drilling, really. The deepest hole, as I recall, is 14 kilometers on the Kola Peninsula up in northern Russia. And there's been a couple of other deep holes as well in Germany and one recently in China. So drilling a Moho in the continents is still out of reach. The problem is, it's very deep and it gets very hot as well. So the idea was, well, in the oceans, it's only 6 kilometers, typically in the Pacific, say, the crust. So we can drill a Moho through this 6 kilometers and get into the mantle. And they tried a few times. So they tried it. The first real effort was a hole called 504B, and that was in the first days of ODP. So DSDP, Deep Sea Drilling Project. Then it became ODP, and then it became IODP. So the program started drilling holes in outcrops of serpentinized peridotite, and that's where we set a new record not in the sense of the first hole into mantle rocks, maybe the 10th hole into mantle rocks that we've drilled, but we drilled by far the deepest with the best recovery. So that's the big achievement that we did. And that aim, even in that expedition 304, 305, the expectation of geophysics and getting rocks from submersibles and dredging up underneath Lost City on the south wall of the Massif was that we would drill into serpentinized peridotite and then fresh peridotite. And so that was the aim, actually, of expeditions 304 and 305 back in 2004-05, was to drill a hole into fresh mantle rocks because the geophysics suggested that. And unfortunately, the geophysics turned out to be a bit misleading, and we drilled a 1,400-meter hole in Gabbro, which is lower crustal rocks and not mantle rocks at all. So a lot of scientists on that expedition were rather disappointed. And so we effectively fulfilled the objective of that by drilling a hole into mantle rocks and serpentinized ones. We didn't get into completely fresh rocks, but we certainly got rocks with about 50% altered, with plenty of olivine still left in them. So anyway, in terms of the program, I mean, IODP was a really valuable program. And one of the first things it did was, I think, on leg 2 or 3 back in the 60s, they drilled a South Atlantic transect. So they drilled with the Glomar Challenger ship a transect of holes from the mid-ocean ridge in the South Atlantic away from that. And they basically proved that the age of the seafloor was progressively older as you went away from the mid-Atlantic ridge. So this was a critical proof of plate tectonics, because the idea of plate tectonics had just come around. The idea that you had spreading ridges in the middle of the Atlantic and the Pacific, where the new crust and new oceanic lithosphere was being generated in a continuous process. And therefore, as you went towards Africa or towards South America, away from the center of the mid-Atlantic ridge, the rocks should become older and older, and they did. So that was a really key thing. But now what's happened with the program is that the JOIDES Resolution, as I say, it's a 50-year-old drilling ship. And it's only got another 5 years of life in it before some environmental certificates and things run out completely. And we've known for a long time that this drill ship needed replacing in order to continue the program. But of course, replacing this drilling ship is an expensive thing. And it's funded in America. It's an American ship funded by NSF, the research council in America. It covers all branches of scientific research. And the scientists from the IODP side had made proposals for a new ship, I don't know, 6 or 7 years ago. And this kept being cut into the long grass by NSF, we'll decide that later. And then we had expected, back in February, the expectation was that the program would be renewed for another 4 years. And we'd have another 4 years of use of the JOIDES Resolution. But we had this rather bombshell announcement in the pages of Nature back in March this year, which said that the NSF had decided that they were not going to continue the program.
And that's how you found out?
That's basically how everyone involved in IODP found out. Even the people in College Station who run the thing didn't know. It seems like the program has consistently, I'm sure it's expensive, but it seems like it's consistently delivered quite groundbreaking results. Yes. Well, it's $70 million a year, the existing program costs.
Hello, no one is available to take your call. Please leave a message after the tone.
Hi, this is Kuan Yu Lin from the University of Delaware. Thank you for having me, and it's a real pleasure to be on the Deep Sea podcast. So I am an igneous petrologist, which means that I study rocks that are formed directly from magmatic processes, like most of the rocks on the ocean floor. And by that, we learn about how the Earth works. So the overarching question that our expedition, which is IODP Expedition 399, is trying to address is the origin of life on Earth, or more precisely, what does the environment that may have cultivated the earliest forms of life look like? And so that brings us to our site, which is known as the Atlantis Massif. It is located at around 30 degrees north in the middle of the Atlantic Ocean, and this is a very special locality where a rock called peridotite, which, you typically can't find until you reach around 4 to 7 kilometers beneath the seafloor. But at this site, these rocks are uplifted by tectonic processes and exposed close to the surface. And therefore, these peridotites are reacting with seawater. And this is where all the magic happens. Right, so this reaction, what we call serpentinization, one of the byproduct of this reaction is hydrogen gas, which in combination with an appropriate catalyst in such hydrothermal systems can lead to abiotic synthesis of organic molecules which provides source of food for microbial life. So yes, previous expeditions at this site have actually found microbes here in the deep sea, and especially in this site where we call the Lost City hydrothermal field, where you can find active venting chimneys of fluid and gas. And thus it has been postulated that this sort of environment might have been an analog of systems where these reactions happened in the early Earth's history and led to the development of life. But an interesting thing here is that along the Mid-Atlantic ridge system, we actually do have quite a few sites that has these type of shallow prototype exposure and serpentinization going on, but none of them really have a hydrothermal system developed in a way that Lost City does. So one obvious question here is there anything unique about these periddotites that are exposed here compared to the others? And this is where we petrologists come in, right? So our role on the ship as petrologists is to characterize the primary features of these rocks. And then after the cruise, we will be in the lab examining their chemical compositions and try to compare them with other periddotites at similar settings to see if these primary rock compositions plays any role in the development of such venting systems. And of course, our scientific party has a really wide range of people from different backgrounds and have different expertise. So for example, we have alteration petrologists who look at how rocks react with fluids. Obviously, there's microbiologists who take rock samples and culture them and try to find living cells in those rocks. There's fluid geochemists that measure the composition of fluids that's circulating in the system, which is really important. There are also like structural geologists that look at all the cracks and how these rocks deform to understand how on earth these rocks were uplifted close to the surface in the first place. And then there's physical property specialists and paleomagnetism specialists, and they measure the physical properties of the rocks such as density, thermal conductivity, magnetism, and so forth. We also have an excellent group of outreach officers that do what they call ship-to-shore broadcast and tours, which is a great venue for students to take a peek at what life is like on a research vessel. And at the same time, they're communicating the science that we're doing to the public and those that are interested, very similar to what you guys do here on the Deep Sea podcast. And then there's also like technical staff who work with the scientists hand in hand to get, some of the analysis done on the ship. There's also a group of really talented drillers that take care of all the drilling, which is an extremely sophisticated process. So you can kind of imagine bringing up a 3-inch diameter core from the seafloor that is under a water column of over 1,000-meter depth on top of all the waves, all the, different weather conditions. And that's just really mind-blowing thinking about it. And most importantly, there's a catering team on the ship that makes wonderful food, way better than anything that I've been feeding myself when I'm on land. And there's also incredible cleaning staff that's always helping us with all the mess that we're creating. Thank you all very much. And so you can imagine that this is a really collaborative environment where people work closely together to meet the scientific objectives, and at the same time, making sure that everyone's well-being is taken care of, everyone is safe and all the operations are conducted under a safe manner. And, of course, nothing ever goes as planned. And so the collaborative atmosphere is really, the key in, we work as a group in responding to all the uncertainties and decision makings, which a lot of times are really stressful, but, that's kind of what life is like. So just mentioning briefly, so everyone works on 12-hour shifts, but quite frankly, given how much work there is to be done, it is really hard sometimes to get off shift on time. And, taking care of oneself, both physically and mentally under such environments is a really important task that, I wasn't really aware of until I got on the boat. So I was like, oh, wow, there's so many things going on. And, you just have to kind of find your own rhythm or routine that works the best for you. And that differs for every individual. And thankfully, there are facilities on the ship like movie rooms, gym, things like that you can help yourself distress if you need to. So yeah, basically that's just a really quick rundown of some of the scientific objectives of the cruise and what is life like on the JOIDES Resolution. And thank you so much for having me. And if you are interested in the scientific outcomes, which will gradually come out in the upcoming years, you can always check out the IODP website. So I'm Kuan Yu Lin from UD, and I'll see you next time.
Hi, my name is Luan Heywood, and I am a marine science technician on the JOIDES Resolution. I also work as a research associate at the International Ocean Discovery Program. That's kind of the land equivalent, which is housed at Texas A&M University. By discipline, I'm an igneous petrologist, but for the last 4 years, I've been working and also living on the JOIDES Resolution for 6 months out of the year. During the expedition, I am one of around 125 people that we have on the ship. And then also each expedition, we have about 20 rotating visiting scientists. As a technician, we are tasked with taking care of the shipboard lab facilities. So on the JOIDES Resolution, we are probably, if not the most, then definitely one of the most well-instrumented laboratory facilities on a ship in the world. So those lab facilities take tons of people to both maintain, but also develop. Most of the equipment that we have on the ship are kind of homemade systems that are built out of commercially available parts. Then during expeditions, since our expeditions take place in super remote areas in the middle of the oceans, if something breaks, as a technician, we would be first on the line to work with people back on shore and then also the manufacturers to try to fix instruments and get them to come back up. The reason why we have so many instruments aboard the JOIDES Resolution is because what we're doing is so unique and also time sensitive. So on each expedition, we are bringing up usually kilometers and kilometers worth of core up from the seafloor onto our ship, where it's then added to this collection. And then we also collect a ton of data on that core. So this is usually stuff about the core that we refer to as ephemeral properties. These are properties that change and are time sensitive. So this might be something like the temperature of the core when it comes up the drill floor, which would give us an idea of the temperature or the geothermal gradient within the Earth's crust at the seafloor, or things like the color, because when you expose geological materials to oxygen, usually the color can start changing pretty quickly. For each expedition, we have some sort of expedition goal. This might be to, say, drill a new hole in a part of the ocean crust that's never been drilled before, or maybe to drill to a certain age horizon or an extinction event, because we're trying to target those rocks so that we can study maybe the Earth's climate before and after that extinction event or something like that. So because of this, we have to assess while we're out there whether or not we have reached the drilling target. So say if we were trying to target a specific age horizon, we would need to have age data while we're on the ship. And for normal on-land expeditions, this might mean getting rocks and then doing some sort of age dating, either radiometric dating or paleontological dating or magnetostratigraphic dating. But since we are out in the middle of the ocean and we're so remote, and for many areas of the ocean, this is kind of the one chance that we get to study that area of the ocean, at least on the 5-year, 10-year scale. We need to make sure that we are reaching our drilling targets while we're out there. So because of that, we have a lot of onboard ship-based labs to try to do geochronology, either via the rock magnetics, the record of the Earth's magnetic field switching from north to south, or by looking at usually micropaleontological data, so tracking the microorganisms and like the skeletons of these fossil planktons and trying to use that to figure out the specific date that a particular sediment was laid down. So as you can imagine, every expedition, we're collecting huge amounts of sample, but we're also collecting huge amounts of shipboard data. And on the technical staff, our responsibility is to make sure that all of those samples and all of that data is retained in a way that's usable for the visiting scientists that are coming onto the ship, but then also for the larger scientific community, because the data itself is released to the public, open source, in data repositories such as Zenodo. And then the samples, after a certain amount of time, are available for any scientist to make an application to get sample material to then study in their specific lab back home. Sailing on the JOIDES Resolution, my favorite and my least favorite thing is this strong sense of community that we have among all of the people that work there. It's kind of like, I explain it like the worst part is that you go to work for 60 days and you never get to leave, and you have to spend all this time with your coworkers and you never get to go home. But really, there's this incredible bond with all of the people out there. Many of the people sailing on the ship have been working out there for decades and decades. And it's just got this incredible energy. And we're people from such incredibly different walks of life, but there's just this overall feel that at the end of the day, we all respect each other and we're all working together towards this common goal.
And that concludes this episode of the Deep Sea Podcast. We now have a support us page to help keep the podcast going. So we've listed lots of ways of helping the show, from free things like leaving a review, subscribing, to lovely, lovely things where you give us cash, like becoming a patron or buying our merch. What I'll say is, though, that if you were sort of on the fence between those two, there's quite a gouge taken out of the merch. We don't get a great deal. To be honest, if you become a patron, we send you some stickers anyway. So if you're on the fence, then the patron route helps us, but we love to see you out in the merch, so feel free to do that. We don't mind at all. And so to wrap up this one, we'll deep see you next time, and I abyss you already. It's funny to read the news on that website because it's just like study after study of, can it help COVID? Can it improve your Wi-Fi signal? Can it make your wife love you more? You know, every single thing is saying like they're doing a study to see if their cure-all can even cure this new thing. But there's never a paper. There's never like, here's what the study found. It's that science washing again.
Wasn't it the guy on YouTube he was a big muscular bodybuilder guy, but he ate nothing but liver?
That's it. Liver King or something like that.
And he was going on about how all you had to do was liver, and it turns out he was like massively into steroids.
Yeah, 12 grand a month on steroids.
Yeah.
It'll be the steroids, mate. It'll be the steroids doing it.
Yeah, I reckon it's that, not just eating awful.